For this project, I took out to analyze some time series data, and I use a time series data library from Rob Hindman. What I did was I installed these packages in R Studio, which allow me to have access to all of these different data sets from different industries, different places, and there's quite a few of them. 648 total time series data sets from this data library, which has a lot of different access to different data points. So what I did was I chose oil prices in constant $1997 from 1870 to 1997. And I have that saved as tree ring time series. I'm not sure why I saved it as tree ring, but with that you can plot tree ring time series, which I've done right here, and this is the starting at the 1870 going all the way to 1997 here, and this gives you kind of the fluctuation in prices, and there's kind of lull right here, but there were quite a few fluctuations, and in order to get rid of a lot of those fluctuations, what I did was I added a smooth moving average to this, which rounded out, so now you don't have as many spikes. You have a pretty fluid moving average. And what this allows you to do with time series data is you can do some forecasting with it. It allows you to kind of see where the data might end up. In this case, I forecast the data here, which gives you the information. Then I can also plot this information. And this forecast is based off of the Holt Winters, which is the beta equals false and the gamma equals false. What the Holt Winters does is it takes the same information that you have and then applies that across the data set. So as you can see, it follows pretty closely. There's a slight deviation between those, but so have this is with a slightly different Holt Winters with the fitted options. And then here we have our differential for T-ring. We'll run this. This kind of gives you can see where this runs out, which with this model, this kind of gives you an idea of whether or not it's ARIMA compatible, and this definitely shows that it is. And then we can run this one as well. And this kind of gives you your correlations, and this is really where it only breaks that 0.2 barrier here is the first two, and the first two here, and we've got our lag max equals 20. And in order to get the best model for the ARIMA set, I ran just the auto ARIMA for tree ring TS, and this gave me the 212 model. And then I can plot that as well. And what this does is it gives me the forecasts. And this is forecasting with its area of uncertainty. Now, when we go up here, you can see how I've assigned a lot of these the forecast on this one. I put the 99.5% accuracy, which is where I get this. Now we can forecast as well, so like you could even forecast without this level here, but we'll change this to forecast 6. And then let's go and forecast this one. And you can see there's a little bit of a difference when you're not adding that 99% certainty from forecast 5. And each one, what I was able to do is I was taking and assigning the algorithm to this so that it would give me each of the forecast options. And in R, it gives you the ability to, when you do forecast, it's giving you pretty certain. You can use that for multiple different, as we said earlier, multiple different industries, and you can kind of get an idea of where and how accurate some of these forecasts are and what a lot of companies do to get that kind of information. And that's where I was earlier, but if we just look at oil prices, 97 to 2000, and we just pull up an image of that, we can kind of see this right here is not too terribly far off of this change here. Got some others as far as your forecast. Yeah. So this is the US dollars and this is the years, and we look at 97 up to 2000. And this kind of follows that forecast, so it's pretty accurate what you can do and how far you can go with some of the forecasting models. And what that does is it's your regressive moving average here as opposed to just your regular smooth moving average, because it kind of gets rid of some of that seasonality, kind of gets rid of some of those fluctuations that you might see. And by that, it gives you a more accurate prediction of what you might see out of some of these data sets. For example, this, like here, we have all of these data points that it gives you, and it takes all of these data points and puts them in and then forecasts that through the ARIMA model. And then I used the time series. So this is really good, using R for time series data, the little book of R, which kind of gives you a breakdown of what a lot of the different options that you can do. I didn't use all of these because not all of these applied to my specific data set. Because as you can see, some of these data sets that they use had a lot of different seasonality variations, whereas mine did not, because I deliberately chose one that didn't have as many variations so that I could kind of get a little bit better forecasting out of it. But yeah, this has kind of been a demo of how you can use the ARIMA model to forecast information and forecast in different industries.